All right, folks, solutions to question number 3. It says find the current in each resistance. That's question. Yeah, find the total resistance. All right, cool. Okay, so the 4 and the 1 become 5 ohm in pure parallel with an 8 ohm. And then we have this other junction of 6 and 2. I'm not going to draw the battery just for simplicity's sake. All right, and then we got the 5 and the 8 in parallel. So let us take care of them. So R equals 1 over 5 plus 1 over 8 to the minus 1, doing it all in one shot, is 3.077 ohms. So again, check your work. Smallest resistor is 5. This is lower than 5. And then we have another junction. So R is going to be 1 over 6 plus 1 over 2 to the minus 1. And that's 1.5 ohms. What's the smallest resistance? 2. 1.5 is better than 2. All right, so now we can draw that we have a 3.077 ohm clump and a 1.5 ohm clump, all hooked up to a 9-volt battery. Total resistance, we have a single loop circuit. The actual total resistance, final I should say, not actual, is the sum of the 3.077 plus the 1.5, which is 4.577 ohms. So that is the equivalent resistance of all of this stuff. So what that means is the battery is producing as much energy as if it had a single 4.6 ohm resistor hooked up to it. Okay, so that's part 1, find the total resistance. Now we're going to find the current in each resistor. So the first thing you do is find the total current that's leaving the battery. So I tote is going to be V over R tote. We got 9 volts and 4.577 ohms, which turns into 1.967 amps. So almost 2 amps. So let's take that back up. And is there really a 3.077 ohm resistor? No, it represents this junction. So that almost 2 amps of current is going to split into I5 and I8. It's going to recombine and become 1.967 amps again. But then, oops, another junction, and then it's going to split into I6 and I2. So we got to find 2 splits. So let's do, I'm going to do the 5 and the 8 first. So I5, which isn't really 5, this is going to be the current through the 4 and the 1. But I'm just going to call that 5. I5 is the resistor you don't care about, which is the 8 over the total as a percent of the total current. And so that is 1.21 amps. I'm going to do the 8 first, and then we'll take it back up to the top to see how it looks with the circuit. So I8 is the resistor you don't care about, the 5 over the total percent of the total current, which is 5/13 of the total current, which is 0.757 amps. You can add these up. I did it on paper, and you get 1.967 back again. But let's go back up and make sure that we put everything in place. So this current and this current are the same, right? There's nowhere for the electrons to go. There's only one path to get through that part of the circuit. So that is 1.21 amps. and this is 0.757 amps. Okay, so just check your work. 5 is less than 8. Yes, that has more current going through than that. All right, then it recombines, and then we got to do the split at the 6 and the 2, and then I think that's the end of the worksheet. So let's do this in blue. So I6 is the resistance you don't care about, the 2 over the 6 plus the 2 times the total current. So 2/8 of the total current, or 1/4, or 0.492 amps. So that's the smallest, because, so even though what's interesting is, even though 6 is less than 8, what's important is how these two compare to each other. And this 2 is 3 times better. So it's not true. That'd be a good true and false question. It's not true that, when things get complicated, that the 6 is guaranteed to have more current going through it than the 8. Am I saying that right? Yeah. Okay, and then I2 is the 6 ohms over 8 ohms times 1.967 amps, or 1.475 amps. Because 6/8 is just such a big percent. So 1.475 amps. Let's see. So then current, let's bring this back to pink. So through the 6, you have almost a half an amp. And through the 2, you have 1.475 amps. So the 2 ohm has more than anybody else. But again, the 6 isn't guaranteed to have more than the 8, even though it has less resistance, because the 2 just took so much of it. Okay, so that is question B. The bonus you may do together on your own, totally optional to turn in. Hope this makes sense, and I'll see you in class.